This is number 61 and 62 from section 3.2. I'll admit I haven't worked this question before, so I'm going to be going at it kind of blindly. It looks like we're given a curve x squared minus xy plus y squared equals 1. And we're asked in 61 for the first derivative and in 62 for the second derivative. So I think we should begin with the first derivative. We're going to take the derivative with respect to x of the left side, x squared, minus xy plus y squared, and on the right, the derivative of 1. So what does that look like? Well, on the left, that's 2x. Then we move on to the minus xy, where we're going to have to use the product rule there because it's an x times a y. So here's what that is. The first function, negative x, times the derivative of the second dy dx, and then plus the second function y times the derivative of the first minus 1. And then we're equal to the derivative, I'm sorry, not equal to yet. We have to get to the y squared term. So plus 2y dy dx, and now we're equal to 0. All right, the dy dx terms stay, the other terms go. So we are going to keep the 2y dy dx, and we're going to keep the negative x dy dx. So that means we have 2y dy dx here and minus x dy dx here. And on the right side of the equation, we've got a positive y and we've got a minus 2x. On the left side of this equation, we lost our place. Left side of this equation, we're going to factor out the dy dx. And that leaves 2y minus x. On the right, y minus 2x. And then we're going to divide by 2y minus x and divide by 2y minus x. And we're going to hope that's one of the answer choices. Y minus 2x over 2y minus x. Yeah, it's answer choice A. So 61, we've got it. That's A. 62, we want the second derivative. So we're going to have to differentiate the derivative. So that's going to look like this. D dx of dy dx equals d dx of y minus 2x over 2y minus x. Let's get to work. So symbolically on the left, this is just the second derivative, d squared y over dx squared. On the right, we have a quotient rule problem. So we start out with low d high and then go minus high d low. So 2y minus x times the derivative of the high function. That's dy dx minus 2 minus high d low. So the high function, y minus 2x times the derivative of the low function, which is 2 dy dx minus 1. This is all over 2y minus x quantity squared. All right, there's a second derivative, and there's a lot going on here. So this is going to require, I'm thinking right now, quite a bit of algebra. I'm hoping I'm wrong, but as of now, this looks like a lot. I think one thing I can do to begin with is treat the 2y minus x like it's one term and just distribute that into the dy dx and into the negative 2. So let's begin with that. So we'll have 2y minus x, I'm going to call it over 1, times a dy dx, and then minus a 2 times 2y minus x. And I should put those both in parentheses, and that's over 1. Next, I'm going to do the same thing over here. So I'm going to take the y minus 2x and distribute it into the 2dy dx and into the negative y. So let's see what we have after that. That's a minus y minus 2x times the 2 times dy dx, and then a minus y minus 2x times a negative 1. So I'm going to call that plus y minus 2x, and that's just over 1. This is all over 2y minus x quantity squared. Okay, I know this seems not great at the moment, but I'm hoping it gets a lot better very soon. We're going to replace the dy dx with what we know the derivative is, which is y minus 2x over 2y minus x. Eventually, it's going to get simpler, but this step I think is going to be more complicated. So 2y minus x over 1 times y minus 2x over 2y minus x. Oh, that's a good thing. The 2y minus x's are going to cancel. Minus 2 times 2y minus x still, minus 2 times y minus 2x, and then times dy dx, which is y minus 2x over 2y minus x plus a y minus 2x. Okay, that's still all over 2y minus x quantity squared. Let's see, those cancel, so that's a good thing. I don't think anything else is going to, though. Not as of right now. Okay, so let's see. I have left in the first term y minus 2x. Then I have minus 2 times 2y minus x. I have minus 2 times minus 2 times a y minus 2x times a y minus 2x over 2y minus x plus a y minus 2x. Does anything here simplify or get easier? I'm thinking as of right now, it does not. Okay, let's go forward with this. Here's a y minus 2x and here's a y minus 2x. That makes 2 of those. I've already got 2 of these, so I'm going to call that squared. Hopefully that helps. 2 y minus 2x's minus 2 2y minus x's minus 2 y minus 2x quantity squared over a 2y minus x. And then this all together is times by that 1 over 2y minus x quantity squared. Okay. At this point, I think we're almost there. I'm going to box this in. Well, I have to choose the box first. I'm going to box that in. I'm going to copy it. We're going to go to the other side of this paper and move it over here, and then deselect and hopefully move on without a whole lot of trouble. I need a common denominator from the 3 terms inside the parentheses. That's a 2y minus x. So this is a 2y minus x, and it gets multiplied by a 2y minus x. This is a 2y minus x, and it gets multiplied on top by a 2y minus x. And we go from there. So we have 2 times a y minus 2x times a 2y minus x minus a 2 times 2y minus x quantity squared minus another 2 times 2y, oops, nope, that's times y minus 2x quantity squared. That's all over 2y minus x. And then we have times that 1 over 2y minus x quantity squared. How do we simplify this? 2y minus x, y minus 2x. Is there anything from the original equation? I don't think so. So I may have gotten myself a little bit lost here unless I just want to expand everything. I guess that's an option. Let's see what happens. If I factor out a 2 of all of this, I can take those away. So let's take 2 out and then expand. We will have 2y squared plus xy minus 4xy and then plus 2y squared. Then we will expand the 2y minus x quantity squared with a minus sign in front. So minus 4y squared. And then 2y times x would be 4x, y with a negative, so plus 4xy, and then minus x squared. And then a minus sign and expand the y minus 2x squared, minus y squared plus 4xy and 4x squared minus 4x squared, I believe. And then on the denominator now, I'm looking at 2y minus x quantity cubed because we got 1 here and 2 there. All right, does any of this help? Let's start with the x squareds. So let's see, I should have an x squared term. Oh yeah, this is supposed to be x. Oops. That's supposed to be x. Right there. So we have a 2x squared, a minus 1x squared, and a minus 4x squared. So 2 minus 1 is 1. 1 minus 4 is negative 3x squared. Let's get rid of those. Let's go to the xy terms. There's minus 4 plus 4 plus 4. So that's 4xy. Next, we want to go to the y squared terms. Oh, no, here's another one. Forgot one. There's one there. So that's actually 5xy. Turn that into a 5. Next, let's go to the y squareds. So there's 2 minus 4 is negative 2. Minus 1 is negative 3y squared. This is over 2y minus x quantity cubed. So is that looking anything like any of my answer choices? 6, 10, 6. Not a lot yet. 1. 3, 5, 3. X squared plus 10xy minus 6y squared. Take out a negative, and then that would be 6x squared minus 10xy plus 6y squared. Does that factor? I don't think so. Well, guys, the answer is A. I'll try to work that one again some other time. I'm ending this video.